Good day. My name is Brian Carlo Rivera, and today I will going to discuss an application of the first fundamental theorem of calculus. We know that the first fundamental theorem of calculus is applicable in this problem because we have a definite integral evaluated from 0 to 1 of this complicated business right here. We ask ourselves, how do we deal with this kind of problem? Because it's a definite integral with plenty of roots. So the first thing that pops in my mind is that we can rewrite this into exponential notation. So assume that we write the given on the right, and it is equal to the definite integral from 0 to 1 of x multiplied by x raised to 1 half. And x raised to 1 half refers to this x. Then we multiply it with x raised to, I refer to this x right here. It is inside the cube root of 3, cube root. Then it is inside the square root. So we have as an exponent 2 multiplied by 3. And then we refer to this x right here. And its exponent is 1 over 2 times 3 times 4. And this is done so on. Dx. Never forget the dx. So we can safely assume that we can multiply a 1 in the denominator because anything multiplied by 1 gives the same result. So what do we notice in the given right now? Yes, you're correct. This is the factorial notation. Very good. So it is equal to 0 to 1 of x multiplied by x raised to 1 over 2 factorial times x raised to 1 over 3 factorial multiplied by x raised to 1 over 4 factorial multiplied and so on dx. Never forget the dx. Now, recall, it is important in mathematics that E is equal to the summation from n equals 0 to infinity of 1 over n factorial, and is equal to 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial and so on. What is the purpose? Why did I write this? Because you can see that there's a pattern being generated right here. This x, you can write a 1 over 1 factorial over here. It is raised to 1 over 1 factorial because it is equal to 1. Now, you can see that in this notation, we have similar bases based on the laws of exponents. What we can do? What do we do? Yes, we put it in a single base. So we write the integral from 0 to 1 of x raised to 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus and so on dx. Never forget the dx. So notice that the exponent is similar to this one. So what is missing? 1 over 0 factorial. So what is 0 factorial? It is 1. Correct. So this is the trick. From 0 to 1, x raised to negative 1 plus 1. Or what is 1 over, what is 1? It is 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus and so on dx. What is the trick? We subtracted the 1 and added a 1 here. So that doesn't change the value of the exponent, right? Because we subtracted the 1 and added a 1. Very good. So what do we notice? This is, yes, this one right here. 0 to 1 of x raised to e minus 1 dx. So what do we see? We have simplified this complicated definite integral to this given. So since e is a constant, we can apply the rules of integrals. So we can safely assume that this is 1 over e, x raised to e, evaluated from x equals 0, x equals 1. We add 1 over e, the exponent e minus 1 plus 1. It is the rule from integration. So we can safely assume and do the first fundamental theorem of calculus, FTC1. So this is 1 over e, 1 raised to e minus 1 over e times 0 raised to e. So what is it? This is 0. This is 1 over e. So therefore, this complicated thing right here just simplifies to 1 over e. Thank you.